Good morning. In our previous experiment, we have discussed how to determine pK value of a given weak acid. So we have n number of liquids, right? We have so many organic liquids. We have benzene. We have so many solvents. In fact, instead of organic liquids, solvent will be a better term. We have water. We have alcohol. We have benzene. We have toluene. Isn't it? So each and every liquid or a solvent have different density. Each and every liquid or solvent have a viscosity. So let us today determine the viscosity coefficient of a given organic liquid. What do you mean by viscosity? So we know that if you take any liquid takes solvent usually will be in the form of liquid, right? So liquid takes the form of a container. If you fill the liquid in this, it will take the form of this. You fill the liquid in this, it take a form of this. So now allow the liquid to flow. Each and every liquid wants to come out first out of the container. When the liquid is coming out of the container, it comes out in the form of the layers. So when it is coming, this is one layer, this is one layer. So there will be friction between the layers. So due to the friction, the overall flow rate of the liquid will be reduced. So due to the friction, resistance will be offered to the flow rate. And that resistance offered to the rate of flow of liquid is called as viscosity. So today, let us see how to determine the viscosity coefficient of a given organic liquid. So there are n number of apparatus to determine the viscosity coefficient of an organic liquid. So but here we are going to use the Ostwald's viscometer. The Ostwald's viscometer is named after the scientist Ostwald, who was the first person to design the viscometer. We have in fact many viscometers named after the person who has invented it or designed it in fact, but Ostwald is the commonly used viscometer. As I have told you earlier, so the layers, a liquid flowing through a cylindrical tube of a uniform diameter moves in the form of molecular layers. So the layers close to the walls of the cylinder is almost stationary, and the layer at the central axis moves fast. So every intermediate layer exerts viscous or friction to its adjacent moving layer in opposite direction. This frictional property is called as viscosity. So already I have told you. So how to perform this experiment? We are going to take the dry viscometer. This is the Ostwald viscometer. The Ostwald viscometer contains an upper bulb here and a lower bulb here. So it has a wider limb and a smaller limb. Through the wider limb you are going to pipette out the liquid, okay, and through the smaller limb you are going to suck the liquid. You are going to suck. There will be a mark above the bulb here and below the bulb here. We are going to suck the liquid using the rubber tubing to above the mark here, and as soon as the liquid reaches the mark, they are going to start the stop clock and wait until the liquid level reaches over the mark below the bulb. Once it reaches there, we are going to stop the stop clock. Okay, so you are going to initially take a dry viscometer. If viscometer contains any water content moisture, the rate of flow resistance for the flow will be higher. Okay, so the dry clean viscometer will be taken. 15 ml of the liquid will be added into the limb, and liquid will be sucked from the other limb, as I told you. So from one mark to the other mark, and rate of flow of liquid will be measured. So this will be done thrice. Okay, so later this viscometer will be dried, washed with acetone. Liquid whichever you have taken will be organic liquid will be transferred to some other container, washed with water, rinsed with acetone and dried. Why are you rinsing with acetone? Because if it contains any impurities, it will remove. If it contains any organic solvent also, it will remove. Other thing is because acetone is a volatile liquid, if it will dry soon. If you take this water, wash with water and keep it in the oven, it may water to convert to vapor 100 degrees Celsius. So to reach 100 degrees Celsius, it takes time. Later to cool down, it takes time. So in order to decrease the experiment time, we are going to rinse it with acetone. That is one of the major things. So you rinse with acetone, dry. Okay, after drying, you are going to cool it. You are going to take the same viscometer pipette. Okay, and whatever you have done, if you have taken 10 ml of the liquid, you are going to take 10 ml of the water and repeat with water 3 times. So we are going to use same viscometer and pipette because the pipette volume changes from one pipette to the other pipette. We are using same viscometer because we are comparing the rate of flow of liquid with that of water. If we change the viscometer, the rate of flow will vary. How it will vary? So each and every pipette will have a capillary inside here. The capillary size varies from one viscometer with the other viscometer. Therefore, we are supposed to use same viscometer, okay, for both liquid and water. So after determining, we have a formula to determine the viscosity. Okay, so viscosity of liquid is equal to rate of time flow of liquid into time flow density of liquid divided by time flow of water into density of water into viscosity of water. Okay, so later the factors which affect the rate of viscosity is, as the molecular weight increases, viscosity also will increase, right? So as the person who is huge will move slowly, right? So similarly, molecular weight increases, viscosity also increases. Polar compounds are more viscous than non-polar ones. Branched chain compounds have higher viscosity than those not involving branches. Straight chain compounds have less viscosity. Temperature has a marked influence on viscosity. So temperature, it is directly proportional to viscosity. As temperature changes, viscosity also will change. I have given a small demonstration on how to perform the experiment. I'll just show you here. This demonstration of how to determine viscosity is given organically. So we have also viscometer here. Then water. Okay, I'm going to pipette out 10 ml of organic liquid here. Okay, this is a granulated pipette. So in this I'm going to pipette out 10 ml of organic liquid. You are keeping the bulb of the viscometer in water, not maintain constant temperature. So going to take from 0. So this organic liquid will be taken and put into the wide bulb of the viscometer. So as discussed earlier, this viscometer will be having two bulbs, one lower bulb, other one is upper bulb. So the upper bulb will have two marks. So we are going to suck the liquid using this rubber tubing from upper into the lower. So I am going to pull the liquid above this mark and wait until the liquid crosses this mark. As soon as the liquid crosses this mark, I am going to stop this. Once the liquid crosses this mark, I am going to start the timer, and once the liquid crosses this mark, I am going to stop the timer. So I am going to measure time taken by the liquid to flow from this point to this point. So I am going to put the liquid using the rubber tubing to the upper bulb. You are supposed to pull the liquid slowly so that it should not come into your mouth, or the liquid should not go into the rubber tubing, and also air bubble should not be there. If air bubble is there, viscosity will increase. You get error. Process this upper mark and then start the timer. So I'm going to start the timer. The timer is started here. You can see. We have to wait until the liquid crosses the lower mark. Viscosity formula is given here. Viscosity of liquid equals time taken for the liquid to flow into density of liquid divided by time taken for the water to flow into density of water into viscosity of water. The time taken of liquid given is recorded by us. Time taken for liquid to flow is recorded by us. The density of liquid, density of water, and viscosity of water are given as constant. So now measuring the time taken for the liquid to flow from the given point from upper limb to the lower limb. So we are going to repeat this 3 times. We will take average. Once it is done, we are going to wash with water. This over. We are going to stop. So it has 110.7. That is the solid. That is liquid. 110.7. So we are going to repeat 110.7 seconds. For liquid similarly. So we have done with liquid. Once done with liquid 3 trials, we are going to throw the liquid, or from where we have taken the liquid, we are going to transfer the liquid into the same container. Wash with acetone, wash with water, rinse with acetone, and keep it for drying. Once it is liquid with water. So going to take 10 ml of the water, deionized water, distilled water, going to fill it in the viscometer and repeat as you have done earlier. So going to set it to 0. So now you can 10 ml of water into this, and going to repeat as you have done earlier. Going to pull this once again. We are going to use same viscometer, same pipette because we are comparing the rate of flow of liquid with that of water. This is a comparison. Therefore, we are going to use same viscometer and same pipette for water as well as for liquid. So, we are using different viscometer. The rate of flow will change because the capillary will vary with viscometer to viscometer. We are using the same pipette because the volume taken also will vary from viscometer to viscometer. So, I am going to take same. We are also going to take dry viscometer. If you have any organic solvent, what will happen? Two layers will be formed. The viscosity will vary. So, always care should be taken that the viscometer solvent are always dry. So, the dry viscometer is taken and measuring the time flow rate of time flow of the water from this point to this point. Once this is done, we will calculate the mean time taken for the liquid, mean time taken for the water, and calculate the viscosity coefficient of given organic liquid at given temperature. So, as temperature increases, the viscosity decreases. Temperature and viscosity are inversely proportional. So, today the temperature is 25 degrees Celsius. By the time you perform your experiments, lab experiments, examination, it may increase or may decrease also. So, we have a number of organic liquids. So, you may get different organic liquids. So, as organic liquid there is, viscosity also will vary. So, let us see what is the time taken. It is 108.9.
So, we are going to repeat it 3 times.
So, when you repeat thrice, when take the mean and calculate the viscosity of given organic liquid. Viscosity formula is time flow of liquid and density of liquid divided by time flow of water and density of water into viscosity coefficient of water. Time flow of liquid is mean is 110.7. Time flow of water is 108.9. Density of given liquid at temperature 25 degrees Celsius is so much. Density of water is so much, and viscosity of water at 25 degrees Celsius is so much. When you substitute and calculate, we get the viscosity of given organic liquid as 9.845 millipoise. This is the answer. So this is how we are going to calculate, and these values will vary with liquid and with temperature. As temperature increases, viscosity will increase. Thank you.
Thank you. PT sir. ರೀ ಏನಂತವ್ರು 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 ರೀ ನಾಳೆ
ಬರಲ್ಲ
ಗೊತ್ತಿಲ್ಲ ಅಕಸ್ಮಾತ್ ಬಂದಿಲ್ಲ ಅಂದರೆ ಕೊಟ್ಬಿಟ್ರಿ ಇದು
ನೋಡಿ ಸರ್ ನೀವು ಹೊಡ್ತಿದ್ದೀರಾ ಸರ್ ನೀವು
ಹೌದು ಸರ್
ಮಾಸ್ಕ್ ತಗೊಂಬಂದಿದ್ದೀನಿ.
ತಗೊಂಡ್ತೀರಾ?
ಬಸ್ಗ ಹೆಂಗೆ
ಎಲ್ಲಿಗೆ?
ಹೋಗೋ ಟ್ರೈನ್ಗ?
ಟ್ರೈನ್ ಸರ್. ಏಕೆ ಏನಾಯಿತು?
ತಗೊಂಬರೋಕ್ಕೆ
ನಾವು ಡೇಟ್ ಎಷ್ಟು? 22 to
ಅಲ್ಲೇ ಇಟ್ಟಿದ್ದು.